Hello, everybody. My name's Phil from American Barbell, and this is American Barbell Unleashed. Welcome today to the first of what I hope will be many episodes regarding educational training. That's mainly the reason why I started this podcast channel, this YouTube channel, and my podcast show, if you will, to kind of help dispel a lot of myths about products and related items to the commercial and fitness industry. And that's what I do. I'm a design manufacturing person of 47 plus years of experience. And my specialty has been everything from selectorized weight stack machines, benches. Then I jumped into weights, bars, and dumbbells in the late 90s, and that's what I do today, as well as re-entering the market of plate-loaded equipment and selectorized weight stack equipment. Today's episode will revolve around Olympic weightlifting bars. And there are so many either myths or misconceptions in regards to Olympic bars in general. First and foremost, Olympic bars are really or can be really dangerous if they're designed and engineered and manufactured wrong. To build a correct Olympic bar, and at this point in my life between 1998 and 2026, I've produced close to 300,000 Olympic bars, all U.S. made materials, components, you name it. The reason why I chose to use U.S. material, especially for the bar shaft, is because that is the most dangerous, the centerpiece with the knurling, the bar shaft. If that is not correctly designed, it can lead to catastrophic failures. So, first and foremost, bars in metallurgy. So, I've been a metal person since I was 12 years old, meaning I learned how to weld. I started to study metals, but I'm in no way, shape, or form a metallurgist. So when I started to design and build Olympic bars in 1998, the first thing I needed to know was how to choose the correct bar shaft material, the center. So I went to metallurgists. I call them metal doctors. These are degreed people that have degrees in the science and the overall knowledge of metal technology and different types of metal and how to properly produce them from raw material into finished products. So basically the science behind it is that when you're making something like an Olympic bar, you don't want just hard materials, because people talk about tensile strengths and all these crazy numbers that we'll get into in a little bit here. But in the case of an Olympic bar, you need a very ductile, elastic material for the bar shaft. The bar shaft, if you think about it, over 30 years, who knows how many cycles? I mean, tens of thousands, if not hundreds of thousands of cycles and or bends. And you need a bar material that is very elastic, that will always return to its normal shape, but it won't become brittle, it won't start to bend, and of course, the last thing on earth we want a bar shaft to do is snap in the middle. So, that being said, material selection is important. Hard versus brittle versus ductile versus elastic, and then let's go to tensile strength truth. So, if I started by, and the more I get into this, and this training center here where we film these podcasts, we've got everything that we produce on display. We have our benches, our racks, our plate-loaded equipment, our stainless products, our dumbbells, our urethane plates, all the things that we've done over the years, and I put it on display, and then I talk people through it. And so the industry is, right now in our commercial fitness industry or the gym industry in general, weights, bars, and dumbbells happen to be the hot topic right now. It's what everybody is buying, and everybody's expounding on weights, bars, dumbbells, rack rig equipment, half rack, dead drop platforms. All of that stuff is crazy popular right now. So what I like to do is walk people through, and I'll start to ask them questions. So in regards to bars, I'll ask a gym owner if they even know what the difference is between a 28 and a 29 millimeter bar. Basically, how do you choose an Olympic bar? And 99% of the time, I will get gym owners that'll say, I didn't even know there was a difference. So in my world, you've got a 25 millimeter bar, which is what is called a woman's bar, primarily in the sport of Olympic weightlifting, IWF weightlifting. That's the International Weightlifting Federation. That's where the criteria is very, very strict in regards to which bar you can only use in a competition. So of course somebody training for that sport in particular will want an exacting bar to an exacting standard, I should say. So for a woman it's 25 millimeter, that's the diameter, how big around it is. A man will use a 28 millimeter bar. Those two bars in particular are designed primarily for people, or only, theoretically, they should be only used by people in the sport of weightlifting. So, and that's what you see people doing on the platform, the clean and the jerk and the snatch, the lifts that people train for to be in the Olympics, I guess, as an end result. In regards to what power lifters like, power lifters or people that bench press, squat, deadlift in some cases, they want a 29 millimeter bar, a little bit different of a grip. And then you get to the knurl aspect. So who wants a rough knurl, who wants a smooth knurl, or a less aggressive knurl, I should say. So again, when choosing a bar, does the buyer, does the gym owner have any clue? No. Now, does the professional or the wannabe professional power lifter or weightlifter know? Yes, they do. So a weightlifter, whether it's a female or a male, 25, 28 millimeter, they want a more passive knurl, smoother, and they don't want a center knurl, a knurl section in the center of the bar because of scraping shins or, your chin or whatever it may be. The power lifter, deadlifter, person that does heavy squats, they want a stiffer bar, larger diameter, 29 millimeter versus a 28 millimeter, so it's bigger, and it's going to be stiffer, and it's going to have a much more aggressive, rougher knurl. That's what they want. So in the case of those two style lifters, there's a clear, definitive path. Now, for many, many years, when I started building bars in 1998, I just built a gym bar. A gym bar didn't have, it was 28.5 millimeter because that's a U.S. material spec, where I'm an international manufacturer, and to do anything in the international community, you have to use millimeters. So obviously 28.5 was right in the middle of a 28 and a 29, and I built gym bars, over 100,000 of them in the late 90s to early to mid 2000s. And that bar in particular didn't have any spec to it. It had a center knurl, it had a decent grip, it wasn't rough and it wasn't smooth, and the knurling did not go to the ends of the bar. So that's one thing to note about an IWF bar or an IPF bar, International Weightlifting Federation, International Powerlifting Federation. Those are designated specs where the knurl goes all the way out, almost to the sleeves. It's about 1/4 of an inch in, and the difference between an IWF bar and an IPF bar, besides diameter, the size, is the grip spacing that you see on an Olympic bar. An IWF weightlifting bar is out wider because Olympic weightlifters like that wider grip, sometimes all the way out to the sleeves. Power lifters prefer a more narrow grip for benching, squatting, whatever, hand location. So now we know about 25, 28, and 29 millimeter bars. So now let's talk for a minute about tensile strength. This is one of my most favorite topics, and there's so much smoke blown at people in regards to tensile strength. So tensile strength is breaking strength. Yield strength is resistance to bending. Excuse me. So anybody skilled in the art of design and manufacturing products in metal or metallurgy or manufacturing Olympic bars, and sadly in our world today, there are very few true manufacturers that make Olympic bars. About 95% of them are imported steel bars, primarily from China. There's no certifications, there's no testing, and more importantly, there's no guarantee you're actually going to ever get what you're asking for, because certifications, testing results, it can be forged all over the world. So I've always dealt with U.S. manufacturers that not only do the processing of the material, they design it from the inside out. They they prepare the cake mix, if you will, for me. So when I buy billets or rounds of bar shaft material, I process it after it's been turned, ground, polished, heat treated, quench tempered, heat treated. It's all goes together to produce the specification that I desire. So when I'm producing a weightlifting bar, I'm going to be a little less tensile, smaller diameter, which is going to give me a more ductile, or some people call it a whippy bar, where it actually has a whip or a bend to it, where a powerlifting bar, they prefer, powerlifters, they want a much, or guys benching, they don't want a whippy bar. They want a much stiffer bar. In my world, the tensile strength isn't a big variation between 190, 195, 200, but because of the increased diameter, that 1 millimeter between 28 and 29, you inherently get a much stiffer bar. So here's some education around bars and bar building, and I always want to kick myself sometimes for teaching my competitors how to build products better. After 47 years, I have a lot of experience. But I'm going to help people understand why it's so important to interview your vendor. So I tell people all the time, you're not going to choose a heart surgeon on the internet. You're not going to go with the cheapest person that, learned how to do heart surgery last week and does it in a van in a parking lot. That's just not how you would do it. For some reason, our industry and the buyers, whether it's, hotel chains, it's private gyms, or it's high-level universities, sports teams, you name it, there's very little buyer education, and that's what this channel is all about, and this series going forward, starting with bars. So here's the part where I'll probably teach a lot of people the science of bar material. When I produce bars, I actually specify the targets or the parameters of the material and the strengths that I'm trying to produce. So again, I let the metallurgist put all the ingredients together, knowing, beforehand, obviously, what I'm trying to produce and what I'm trying to accomplish. A bar that can bend and bend and bend and bend for years and years and years and return to its normal shape and never break. So after I receive that product, that's when I produce it. And what I'll do is I'll machine it, I'll knurl it, and I'll prepare it to build after, producing the sleeves and the whole shooting match here. So back to the tensile strength comment. So when you buy bars and you're skilled in the science, like I feel I am after all these years of how to order material, you order by parameters, meaning min levels of tensile and yield strength. Tensile breaking, yield resistance to bending. So I'll set a parameter of 190 and 170. 190 tensile, 170. That means that any material I ever receive cannot be below those targets, but they're always going to be above. So when I look at my test reports, they'll come in at 190, 221, or 192, 436, whatever, you get the point. But they'll never, ever come in at 190. So when we specify our bars and what we're saying the strengths are, we specify our target. It's our min, it'll never be below that. And that's the guarantee I receive from the manufacturers that I buy the material from. So knowing what you know now, if 190 is a target, why would I ever say 191? So, point in case, there's companies out there that quote 216 tensile, 236 tensile. That means 236,000 pounds per square inch breaking strength, tensile strength, PSI, pounds per square inch. So I tell people when I'm giving educational seminars, and I love to point this out, I say that immediately exposes an inexperienced manufacturer, because no one would ever say 236, 216, 211. It's a target. So if it's a target, they should have said 235 or 215. So, of course, I would love to ask a manufacturer like that, so do you have paperwork to show that it's 236? No. And furthermore, I can tell you that it's nearly impossible to machine bar shaft material above 200. At one time, 20 years ago, I attempted to machine some stainless that was hard. It was probably 215,000 PSI tensile strength, pounds per square inch, tensile strength, and we couldn't machine it. We actually had to send it. Well, we could machine it, but it was so brutal on the tooling, it was going to kill us on the cost. So we sent it back to have it annealed, which means softened, and then reheat treated. So for me, it's laughable when anybody quotes 236 tensile or 235 or 240, especially for a weightlifting bar. A weightlifter, Olympic weightlifter, would never want to bar that stiff. It'd drill them right into the ground. So if you think about a person taking 400 pounds and doing an Olympic lift up to the chest or over their head, they want that thing to flex, to bend. That's what an Olympic weightlifter wants. A power lifter does not want that. They want it stiff. So a good power bar ranges between 190 and 200. So anybody telling you that their bars are over 200, they have to be doing one of two things. They either have to have amazing tooling and don't care about getting 1 or 2 bars per set of knurl dies, which are not cheap, or they could do something that I've done in the past where I machine it and heat treat it after the fact. The problem of heat treating it when it's, or machining it when it's softer, and then heat treating it to the hardness you want after, you have finish discoloration and things like that, and it's obviously not very feasible to try to put a chrome finish or anything else on a bar that's turned blue from heat treating. So, tensile. What's real? Interview your vendor, ask for test certificates, and uncover the myths and the inexperience. We know what we're doing. We know that people don't need overly hard bars, overly stiff bars. And the most important thing to note about an overly stiff bar is the higher the tensile, the more possibilities of that bar being brittle, meaning it can snap. And that's the last thing we want a bar to do, is snap. So when people talk to me about bars breaking, there's 2 ways you'll see a bar break. It'll snap at the sleeve. That's a bearing failure, a needle bearing failure, 9.999 times out of 10. And if a bar ever snaps in the middle of the shaft, that's a heat treat or a preparation of the material that was done wrong. And you've received material that was brittle, and that can be a catastrophic failure. There's been cases, sadly, from many, many years ago, of people on their back doing bench presses and the bar shaft sheared in the middle and went through people's necks, and people have died from stuff like that. So now we've got a good tutorial on tensile and what's real and what you really expect. And remember, let's see now how many people adjust their marketing materials to 235 and 215. And again, I always tell people, please verify, check my information, and if I'm wrong, please let me know. But I definitely know that I'm not wrong about that. Thanks, everybody, for tuning in to American Barbell Unleashed. Please like and subscribe, and stay tuned for the next episode.